Okay, welcome to our last week of new instruction. We're going to start with independent and dependent events. So a good way to start this is to look at what does independent even mean. We see that independent, if I look for a definition, means free from outside control, not depending on another's authority. Right? So if you're being independent, you wouldn't be able to be controlled from the outside or from outside of you. And nothing else will really affect you. And that's exactly what an independent event is. So, what are dependent events? Dependent events are when the outcome of one event does affect the outcome of another event. Okay, they're considered dependent events. The second event would depend on the first. Okay, what are independent events? Independent events are when the outcome of one event does not affect the outcome of another event. Okay, so when it's not dependent on the first. For example, if I were picking a marble out of a bag of marbles, and I picked one out and that one was red, and then without putting it back in, I pick out another one, those are dependent events, right? Because the fact that I never put that first red marble back in the bag means that my second pull is a little bit changed, right? It's changed by the fact that there's one less red marble in the bag. Whereas an independent event would be if I put that red marble back in, and it was the same exact experiment over again, right? In the same bag twice. Those would be independent events because my second pick does not depend on the first. And what we're going to look at here for the example is picking out of a deck of cards, out of a deck of 52 playing cards. So if Sam picks a card from a full deck of 52 cards, without replacing the card, he's going to pick again. So he's going to pick a card. He's not going to replace it. He's going to keep that card out, and he's going to pick another card. Okay. What is the probability that he picks the ace of hearts and then the ace of diamonds? Okay. These are going to be considered independent events dependent events, because the first time he picked, he had a 1 out of 52 chance of picking the ace of hearts, right? There are 52 cards in there. He has a 1 in 52 chance of picking out the ace of hearts. And then the second time he picks, the deck is not quite the same, right? There's one fewer card in there. So now to pick the ace of diamonds, there's now a 1 out of 51 chance of picking the ace of diamonds because there's one fewer card, right? We never put that first card back in. So these, because he did not replace the card, these are dependent events, right? The first event of picking that first card did affect the second event. On the other hand, looking at independent event would be if he picked two cards again from that 52 card deck, but he replaces the card instead and picks again. What's the chance he picks the ace of hearts and then the ace of diamonds? So the first time he picks, he has a 1 out of 52 chance of picking the ace of hearts, right? There are 52 cards in the deck. He puts that card, the ace of hearts, back in the deck. And he picks a second time. Now again, to pick the ace of diamonds this time, he has another 1 out of 52 chance, because we have all 52 cards back in the deck. Okay, so because he replaced the card this time, the first event does not affect the second event. The fact that we picked the ace of hearts the first time does not change the second picking the ace of diamonds, because we put that card back in. Okay, so there's a slight difference, but that's a difference between dependent and independent events. Right? Dependent means the second event is affected by the first in some fashion. An independent event would mean that the second event is not affected at all from the first one. And we can look at finding the actual probability, again, kind of like the fundamental counting principle, by just multiplying the probability of the first event times the probability of the second event. So we just got to multiply. So if we look at picking those two cards, what's the probability of picking the ace of hearts and then diamonds without replacing? So I pick a card, it's the ace of hearts. I pick another card, is the ace of diamonds. So here we have the probability of picking the ace of hearts on the first card. Like we said, is a 1 out of 52 chance. There are 52 cards in the deck, and there's only one card we're looking for. So it's 1 out of 52 chance we pick an ace of hearts on the first card. Now let's assume we pull that ace of hearts. Without putting that card back in, I'm going to pick again and look for the ace of diamonds on that second card. Now there's one card I'm looking for out of only 51 cards, right? Because I didn't put the first card back, so it changes the event a little bit, right? Dependent events here. So it's a 1 out of 52 chance for picking the ace of hearts the first time times a 1 out of 51 chance of picking exactly the ace of diamonds on the second card. When I multiply straight across, 1 times 1 is 1, and 52 times 51 is 2,652. So the chances of you picking the ace of hearts and then the ace of diamonds without replacing that card is a 1 out of 2,652 chance. Okay, if I were to, let's see, go to my calculator here. 1 divided by 2,652, is a 0.04% chance. Less than a percent, less than a fraction of a percent chance of picking an ace of hearts and then an ace of diamonds. Let's see, are the odds going to be better or worse if you replace that first card? So if I put that first card back in after picking the ace of hearts, is it going to be worse or better? Let's look. Again, the probability of picking the ace of hearts on the first card is 1 out of 52 chance. I'm looking for exactly the ace of hearts out of 52 cards. Okay, so it's a 1 out of 52 chance times, because I multiply the probabilities together. If I put that card back in now, right, again, there's going to be 52 cards in the deck again, right, because I'm replacing the card back in after picking it first. So 1 out of 52 chance of picking ace of hearts, put the card back in, times 1 out of 52 chance I pick the ace of diamonds on the second card. Okay, multiply straight across, I get 1 out of 2,704. So it's a little bit worse chance of when you replace the cards that you get the ace of hearts and then the ace of diamonds. Again, big reminder here, to find the probability of two events like this, you just multiply their probabilities together. Okay, we're going to finish off by a little bit of sorting here. So I want you to take some time. There are 5 different options, or 5 different events here. I want you to place them into the independent or dependent columns, right? Or is this an independent or a dependent event? Okay, so let's look here. The first one, picking a marble out of a bag, then picking another marble without replacing the first. The big key important thing here is the word without, right? Without replacing the first one. So we pick a marble, we don't put it back in, we take out a second marble. That's going to be dependent, right? My second action of picking out a second marble is changed by whatever the first marble is pulled out, right? If I pull out a red marble the first time, there's one less red marble in the bag. If there's a blue marble picked out first, it changes the outcome of my second one a little bit, right? Because there's one fewer blue marble in the bag. Flipping 3 coins. This is going to be independent. Because if I flip 3 different coins, the outcome of the first one does not affect my flipping of the second coin, right? The 2 coins are not connected at all. I could get a heads on the first one, and my second one is not affected by the fact that the first one was heads, right? So these are independent events there. picking a card out of a deck, shuffling the remaining cards, then picking another card from the deck. So, because it doesn't sound like that first card goes back in the deck, right? There was 52 cards in the first pull. But if I don't put that card back in, now there's only 51 cards in the deck. Okay, so these would be dependent because I didn't put the first card back in. I didn't replace it. All right, there's 1 out of 52 chance the first time. If I pull that card out and I don't put it back in, there's a 1 out of 51 chance of me pulling a certain card the second time. Okay, because the first action changes the second event. Spinning a spinner 5 times. This is going to be independent, right? If I spin a spinner and it lands on red, right? The second time I spin the spinner, it's not going to change based on the fact that the first one is red, right? We could get red again. We can get any of the other outcomes just the same as the first event. So those events are not affected by each other. Rolling a pair of dice, then re-rolling those dice again. Dice rolling, it turns out, is independent. Right? If I roll 2 dice and I roll an 8, the second time I roll those dice, it's not going to be nothing will be affected by the fact that I rolled an 8 the first time. Right? The second dice roll is completely independent from the first. So again, the big key thing here is, are these dependent or independent events? Right? Dependent being when the second event does depend on the first event. Independent events are when the second event does not depend on the first. Okay, and the other thing we focused on here was when we're finding the probability of 2 events, we need to multiply the probability of the first event times the probability of the second event.